Welcome back to another stack language compiler session, and today the goal is to at least start on the parser and maybe parse just a little bit and then move everything from the tokenizer, like have a pipeline tokenizer, parser and assembler, because we have the tokenizer, we have the assembler, we just need the parser, right, to actually build automatically the ASD or not manually. So yeah, anyways. And yesterday I did a few changes to stdlib and the C compiler. I just moved every external declared thing into the C compiler because I thought, well, those things should actually be part of the base of the language. So you don't have to import stdlib to have access to integers, pointers, and so on. But if you want to use anything else, you have to include stdlib, I guess. And also added this file, line, and column constants, which are like magic constants implemented in C. And basically they give you the current file, the current line, and column, right? So we can have nicer panic messages like unwrap, like Rust, and to do message, right? So I think that looks a bit nicer. So if I have like a file, right, which runs a panic, and it shows you the file, line, and column, right? So if we go to 06, you can see that panic is on line 4, column 5. So maybe it's gonna be useful, when we don't implement something, we are gonna put something like to do comment. Yeah. So that would be the one of the changes. And the other thing is, no idea why, but because of constant expansion, I wasn't able to free the memory anymore. I was getting invalid freeze. If if you are interested, just to know that the memcheck dream is gone, right? And yeah, I mean, I would say it's fine because we are anyways moving to stack, so I don't really care about the C code anymore. It can go to shit, but yeah, I mean, it was nice while it lasted, right? I mean, but CEC, you cannot, like, it's hard to have perfect memory management in a single file program. Just wrote, anyways. So yeah, basically the stack preprocessor causes some leaks, right? So yeah, some leaks, and then I have like freeing stuff multiple times. So yeah, it is what it is. But anyways, so in stack, as you know, I finished the tokenizer from the last time, and the goal is to start with the lexer, and I just create with the parser, sorry, and I just created this these like small functions for our parser. So a parser is going to have a reference to a lexer and the tokens, like the current one and the next one. So that would be the idea for our parser, the same as we do in C, basically, right? So yeah, then we'll have the AST, and again, I think it's because stack parser parse is gonna be a recursive function, I'm gonna put the result into the argument, right? So I think that's a good way to do it. And then, whatever we unwrap, and at the end we are left with the args and the AST of the language of the file. So I think that's kind of good, right? We are left with the AST. I don't think we need the lexer or the parser after this step, so it's fine to discard them. So yeah, after this one, it's gonna be the stack AST. And what can we do with the stack AST? I guess where is the stack assembler emit? Right, we can take this thing. mean, I could have done this the last time, but so we have the emit function, which if I get to the actual definition, wow, I have so many. Okay, here it is. So it takes a stack assembler and stack AST. We already have the stack AST, that's good. So stack, what does the assembler need? Wow, fine. So it needs a few things, right? It needs an integer. Oh, but I think if we go back to stack data stack assembler, I think it has an init function, init with fd, right? So we have this init with fd, which is gonna take only the file descriptor, and the file descriptor is in the args. So I can do something like swap, took the arguments, then stack args dot I guess the file, oh, I could save it here so we don't lose the fd, because we might want to also close the file. So we have fd, here we have still fd, here instead of that we have to rot and rot prime, right, rot prime. So here it's like fd, I mean, we'll see if type checking doesn't work, right? So that's the, if we do rot prime, it should be fd like this. All right, so we have this structure, and then and then here I would probably do swap loop again. So we have args stack st fd fd, and if we initialize the assembler, we lose one of the fds and we get a assembler, right? So just to keep the same structure, I would also push back the fd, and yeah, now we have the AST and the assembler, and we need to swap first, right? And we are going to be left with args and fd after this stage, right? Because this takes assembler and AST and doesn't return anything. Nice. So we are left with args and fd, and somehow at the end we need to do something like stdlib.f close to close our file descriptor, right? And def close can fail, so we unwrap, and then we can just pop the arguments, right? So I think we have some errors obviously in 66. Holy shit. Here, so on the first branch I have stack int args, okay, and on the like what do we need to return. So stack, okay, let's see, we need to return int stack args basically, because that's the else case. File descriptor lexer args, file descriptor lexer args. Okay, so we have file descriptor lexer args. We swap these two together, we duplicate the lexer, we dump, so we have fd args stack lexer, we say 0sys exit, and then we just need to swap. Yeah, we need to swap, so we have args like this, and we push back the args with rot prime, so we get this. Nice. So now we should be able to have the same thing, right? So obviously nothing will happen now for the ASD, right? Because we don't actually build it. We have to implement the parse function. Right, so that's the to-do for today. Maybe before that, what I'm also gonna add is, I mean, you can see that if you run main help, it shows us also the parser. So let's add the parser stage to our oh, let's actually add the parser stage. So we string std out, and then here we do something like this. Yeah, string.std out. So we can also stop the parser phase, right? And here we just need to do this kind of stuff. Parser p, we need to close the if. Here we need to say we set the parser, right? And now the parser should take another boolean parser, or I guess, yeah, the arg parse. Okay, and we initialize it with another false, right? So now if we go to our main, we should have something like rot dup stack args parser if. So this is going to be still stack stack lexer. Oh, it's stack st, yeah, I was right. Stack st args swap dup stack st dump, right? I mean, it's the same like the C code, I think. We do stack st dump, right? Stack st dump. After this one, we'll have args stack lexer with 0sys exit, swap back, and then p rot prime stack st. Right, so if we run make, it should be fine. Okay, but we don't have stack st dump. Yeah, so we don't have stack st dump. We can add that as well just to have it. So stack st dump, I'll just add it here. Stack st dump takes a stack st, doesn't return anything, and it's basically to do pop. And I think it's a better idea to do first, so that it just fails instantly. So yeah, if we rerun make, and run the tests, it should still work. And if we try to run SLC, let's say we try to run the Lexer, it works. If we try to run the parser, it's gonna say to do 236. So first things first, we need to implement stack parser init with Lexer. Interesting. So what do we need to do here is, if we take a look at main.c, at stack parser init, right, we do this extra step of stack parser read. We do that extra step of stack parser read. So after we initialize our stack parser, we need to call to read once, right? And that's just to initialize. So if we go to definition, it just initializes the tokens, right? So let's implement these helper functions. So stack parser peak, that's the first one. It just returns next token. So it takes stack parser and it returns a stack token, right? Yeah, stack token. So what it does is just stack parser and it calls to next token. So it's, I mean, it's just a rename of next token, nothing much. And then we have stack parser read, but I just want to keep the same conventions, kind of. This one assigns, okay, this one is more interesting, but it also returns a token. Okay, so it assigns the next token to the current token, so it shifts forward, and then it reads the next token. So yeah, basically we have to run a loop. So we have the parser twice, PA, let's call it. Then we need to call parser peak. So maybe we need to even do more to be able to do that. So I would say then that we need to parser peak, stack parser peak. So now we have a token here, token, right? And now we need to call to stack parser token set, right? So we set the token and we are left with stack parser in the end, which is nice. And next we need to do the same thing, kind of, for next token. So let's copy up until this point. So we have PA. Then we need to access the lexer of this parser. So stack parser.lexer. Right, why do we need that? Well, we need to call stack lexer.next, right, which gives us a token, stack lexer.next. We actually find the definition, right, it's here. Stack lexer next takes a lexer, returns a token. Nice. So that's gonna give us the next token, and then we need to set the next token. So stack parser next token dot set, and at the end we'll still have just the parser, right? And finally we need to return doc, so we can just say stack parser.doc, and that's everything for the read function. And the read function is just giving us the next token. That's all it does. Okay, so now we can finish our stack parser init. So as I said, here we need to do and stack parser dot read and maybe pop the token. I can even put it on the next one, and we no longer need to do. Right. I mean, this single issue here is that talk initially is gonna be empty, but first thing you have to do is always read, so it's fine. Like, yeah, obviously the parser is gonna start empty, so that's good. We could also add this show error, but I think I'm just gonna panic in case of errors initially. So yeah, what's next? We don't have to worry about freeing memory because we don't do memory management. That's just how things go. Right. So currently we only have AST functions, which, you know, it's not ideal, but it is what it is. So another thing we can do, so we have node condition. Let's put it like this. So we have nodes, expressions, conditions which contain expressions, right? I mean, it's kind of true. Expression and condition, like expressions. Why do I have a pointer? Oh, this is only one expression, right? Yeah, this is only one expression. So, I mean, it's fine. Like a condition can contain multiple expressions, and an expression can be a condition. So, but here you can see we have this kind, and I should probably take this enum. Let's call it enum right here. All right, so in case, I mean, yeah, maybe it makes sense to move this one here then. So yeah, it's like if you have expression number and so on, it's just AST node. If you have a condition, then it's the condition data, right? And that's an expression. And then we have functions. And here I would change this one to be const stack AST func 0, and now stack AST is gonna have an array of features. Let's call them features, feature function, and data stack AST feature is gonna have a kind and pointer to the feature, I guess. And feature can be, for now it can only be function. This is a small change compared to main.c, and the reason why, honestly, is you can see that stack AST prog has a list for every like thing. I'm not sure if I want to merge all of these lists together or keep them separate, so I think it's going to be easier to merge them together in this language especially. So let's try to do that. I mean, why not? We'll see how things go. So initially, as I said, I think I'm going to have only features, although we also need data structures for let's also put data, why not? So data is stack AST data. It's basically just a name for now. let's just say it's a name for now. Obviously in the future it's going to have the fields, but yeah, I mean, yeah, whatever. Also the functions will require the types. Okay, anyway, so what's next? Stack htdump, it's gonna happen at some point, but stack parser parse is more of what we need to do. So let me just move this function up here. And how does stack parser parse actually work? Well, stack parser parse. So obviously it's going to be a while loop, I mean a recursive loop, and we are going to try to pick some token and see what kind of token it is. We have multiple choices. Right, so let's try to do something like that. Question is, can I think I can use the parse function as recursive. So what we are gonna do, well, first let's make sure we don't have any errors. So let's make 234. I think it's next stock. And I have another one undefined, stack st funcs 498. Huh. I mean, because I changed this part, right? So this one should become a to-do then. So we have swap stack st and assembler. I mean, I can just to-do, I guess, and it's gonna be fine, right? Because right now we should have a for loop, and depending on the type or the kind of the node of the feature, we should do something different. So next run elixir, that's good. And if we try to like slc the parser, we still get a 243 error. So now we have the error here, the parse. Right. So as I said, we need to have a for loop. So how can we do that? Is so you can see the for loop depends kind of on the parser pick. So let's try to call parser pick. So I'm gonna swap a dupe. So we have st and parser twice. So we can stack parser pick. Alright, so we get like a token. And now we have some ifs, right? And I'm curious, all right, so if it's end of file, we stop. If it's end of file, we stop. That's a success, basically. So I have the AST, the parser, and the token. So we can duplicate it, stack token, end of file. right? If it's the case, then this should be kind of successful. Interesting. I think this should also take the boolean as input. Right, or at least something like that. Like the parser data tag parser doesn't really have a failure, so maybe this one also needs a boolean here. So yeah, maybe it's nicer to have a separate function that actually instantiates those things for us, so we don't have to think about adding this thing. Right, so we just have the parser, and after we call parse, we just get those things. So this should add the AST on top, and maybe even a true for OK. Right, and then we can stack parse prime, and this should give us AST and OK. Right, so it's gonna be a bit easier. Anyway, so we basically have parser AST OK. So here we want to rot duplicate, so we have parser. We have the token. If the token is end of file, we can just so this is also gonna be like what the if contains, right? So I can just pop 2 basically, and these things should give us stack and OK. So what's happening on the else case is gonna be more interesting, I guess. And on the else case, what do we have? We have to duplicate the token. It's AST parser token. We have to duplicate the token and check for each of these things. So data, function, import, const. All right. Stack token data equals. We have an if. AST parser token. That's gonna be that, and we need to return AST and OK. Then we check for stack token function. We add a fee, we add the else, we check for stack token import, we add an else, we add a fee, and lastly we check for token const. We add the else and the fee, and here we need to return an error. So we can just like pop3 false, right? So we return an error. Sure, we could also show a message, but what I think I'm gonna do actually is just panic, or like to do, and because we don't have that. I mean, let's just to do pop2 for everything. Right, and let's try to make this thing. equals has non-matching args. That's what you think. 243. Okay, what? Oh, it's stack token. Yeah, that's true. That's true. I'm interested only in the kind of the token at this stage. I don't care about the value. Although the value is nice, so the value is nice for error messages. So I need to call right stack token kind. It's kind of inconvenient, but whatever. I could have duplicated the kind as well, but it's like, yeah, whatever, let's just keep it like this. I'm fine. Anyway, all right, and now it's gonna complain 247. So in this if, it says that left hand side returns stack boolean parser token and right hand side returns only stack and boolean. Oh, I forgot about the to do comment here. Right, so we just to do everything, and now if we run the parser, we are gonna get the to do at 250. So it was a function, the first thing. So let's start with the functions then. If the first thing we have is a function, we just start with the functions. So how do we parse a function? Function stack parser parse func. Sure, why not? So we take a stack parser, we take, I'd like to also take the stack st boolean. So let's just check in here. When I parse a function, yeah, I like more the idea of sending the actual st func instead of the entire st. So stack st func, a boolean, and we return a stack st func and the boolean, right? So we basically get the parser, the result, and the results, kind of, right? So the function and okay. So these are the results. Although although this thing doesn't really need the results because I don't think it's recursive, right? It's not really recursive. But does that matter? Somehow it feels a bit better if you do it like this. So imagine I do, okay, let me just end it. Imagine I do something like pop the token, then I create a stack function. So how do I create a stack st function? With name and array. So I should have a stack st func init empty. That's why I say not sure if I like stack st func, right? And I mean, node doesn't really have a stack st. I mean, now it has. Right, we can initialize an empty function, for instance, but it's like maybe sending the okay, like the boolean makes sense, but sending the ast function doesn't really make sense. I don't know, not even the boolean makes sense, to be honest. Right, like I wouldn't really send this because it's like weird to initialize an empty function. Okay, anyway, so let's do it like this. Though I'm not sure about the boolean. So I would do like what if, right? Like should I start an if? I don't think so. Anyway, so yeah, we just popped the token because we don't need it. It's kind of useless in this case. So we swap the parser and the OK, and we stack parser parse function. This is gonna give us st. See, we lose the parser, so let me just loop rot. So in this case, we are gonna have parser stack st, or like function and OK, right? We have these. I could unwrap, right? And then what can I do? Parser and function. I would say I want the a way to append stuff to the parser. Right, a way to append stuff to the parser. Or I'm wrong, I want to append stuff to the st. Where is the st? It's here. Obviously it's gonna be like append feature, but function stack st dot features dot append, and it should take a stack st feature and the stack st. I don't think it should return anything. I guess. So first thing is to swap. So we have a feature and st, and what's next? Feature and st. I would dupe the st. Let's stack st dot features. We get the array. I think we need to rot forward. So we feature, and should we do array? So the feature is gonna be this is gonna be an array of features, so it's fine. I should do array.append, and array.append it's funny, I think we don't even need to duplicate because we change the pointer. So if we just swap, so we have the feature and the ast, and then we take the array, and then we swap and append, we just get this, right? And we don't need to reset the array because I think the array is a pointer. It's like the address, so it should change the actual, or at least that's what I think. Like if we access this thing, the memory allocated is the same. We don't copy the memory, so it should point to the same memory. So stack features append, it adds a feature, and I can do stuff like features append function, and it takes stack ast func, and now we can do stuff like stack ast feature function. So we add the feature flag. Maybe first we stack ast function reference, then we swap and stack ast feature.init, and then we can just call to features.append. So basically we reference our function, we create a pointer out of it, we add the flag or the kind, we initialize the feature, and then we append the feature to the ast. So that's just a helper function for like appending functions to the ast, right? So if we come here, we need to have ast and function as the, I know what, I shouldn't unwrap because this thing apparently returns okay, so it's fine. So let's not unwrap. So it also has okay. So to be able to call this function, you can see it's ast and function. So let's bring these guys forward. I can do something like rot4 and then rot, and this should create something like parser okay ast func. Then we can just call to this thing, and we get parser and okay in the end. Parser and okay. Oh, but I lost. Okay, then let's dupe and rot4 again, so we get also the ast. Right, so that's how we get this thing. And here at the end we kind of need to stack ast parse recursively, right? We need to parse recursively, and to be able to parse recursively we need, actually here we need something else. We need parser ast boolean, so we need to return the parser. So here I should only pop and rot prime, actually. Pop rot prime, pop false, I guess. Whatever, doesn't really matter. So we get that, and here we just return ast and okay. Right, so that's fine. Okay, let's remove that. I don't need it. So yeah, I think that's good. So it appends the function to the ast. I mean, if it fails, it fails, but we append it. Honestly, I would unwrap and then call true. Right, if you know what I mean. Unwrap true. and basically this will just crash the program if it fails, and otherwise it will put a true on the stack. So that looks good, I think. Okay, so I think this should at least try to call this function. Right. So let's go next. Let's try to implement this one now. So what do we need to do in this parse function? Well, initialize everything. Can do that at some point. We need to parse a func token. I mean, we need to parse it again, which is a bit weird, but it's fine. This time, instead of using peek, we have to use read though. So that's the only difference. So let's swap. So we have the OK last, and then we have a parser. Right? We dupe. I'm gonna call it P. Stack parser read. So we get a token. I should duplicate it again, but I'm not gonna do that. I'm just gonna do stack token kind. So we get a kind. Maybe here it's worth to say like, okay, parsing. We get the kind, and then I have to say stack token func equals not. I mean, if to do, right? Or panic. I guess to do. So if it's not true, I show a to do comment with this line, and basically I will know that, well, we need to handle the error case if you have a not a function token, right? So I think it makes sense. So basically we remove the kind into a boolean, then we negate that boolean, and then we consume it with the if statement. So here we'll have OK and parser. Obviously it would make sense to make I mean, I just don't know how I feel about sending this boolean into these functions. It's a bit annoying, especially because I'm just gonna unwrap everything, so why bother with it? So let's just remove it because it's not really ideal. So we have just the parser here. I mean, it's a bit annoying. So if here we are getting only the parser and the st, here we need just to swap. We duplicate the parser, we pick the parser, we pick the token, we duplicate the token, get the kind, check that so we don't have this thing. Even here, like, should I return I don't think so, but we still pop 2. Okay, then here I'm gonna to do and basically pop 2. I guess so. So that's the new condition to do pop2. All right, and here we actually just return that, just the AST. And now I need to fix this one. So it's gonna be, let's pop the token. I don't care about the token. We duplicate the parser. We duplicate the parser. We just parse the function with the parser. So we get AST parser function. I don't do this unwrap. AST parser function. Then I can just rotate the AST forward, duplicate it, rotate the function forward, call to append function, and we are gonna get parser and AST. Okay, yeah. Anyway, let's continue with this part. So we have the parser because we successfully read a function token. Now we need to read a name token. So let's try to do that. If it's a name, but in this case we need to save this token. So I might do something like dupe here. And so we have basically parser, token, then we get the kind, we convert it to a boolean. If it's not, then we are gonna fail. And here we have a token. Right, and it should be something like if we don't fail, that's when we get the token back, right? So this token should be a name token. I don't even remember data stack token. It has a bunch of stuff. Nice. Right, so it has a bunch of stuff in it. For example, what we need is the value, maybe the position. Maybe the position, right? So we need to initialize the name, so stack AST node, right? So I would like to have stack token dot position and stack, and then I guess swap stack token dot value, or should I put them value position? So it's like we have the token twice, toc, then value, and then we swap, and then we take position, and we have value and position, and then we can say stack AST node dot init. And the other cool thing would be to have a dupe2 actually. So why do I want a dupe2? Well, we'll have parser token, right? Then we take value like this. So we have value. We rotate the token forward. We take position, And now we initialize the AST node with these three things, with the parser, with the value, and the position. So we just need a parser for the file name, that's fair, and for the lexer to be able to convert position into line column. So I think that's a good point. So here we have a node. So after this thing, we'll have parser and the name of the function, right? Now stack AST node. You can see that it needs parser value position. Parser value position. Stack parser. Value int pos. Right, it needs all of these. It's gonna be interesting if I want to add some random nodes, because they'll need a parser, but I don't have a parser. I mean, we'll see how we'll do that. Maybe we'll have like a default parser for those things. Anyway, we get the parser and the name, right? So ideally I would push back the name because it's gonna be needed only at the end. And now we continue with our parser. So next up is parsing the arguments and return values. I would say those are to-dos, so I'll just put a comment. Add args and returns, right? When we are gonna start with type checking. Right now I don't really care about that. So let's force an in read, right? We need to force reading an in statement or like an in token. So this is how we are gonna force that. Now we are sure we read an in, and we kind of need a while loop for the body. So let's say I'm gonna do a function stack parser parse xparse until, I mean, it's gonna be interesting. I think parse expressions until might be a good function. So we are gonna have the stack parser. We need the until token, so it's an int, it is what it is. I would also pass the array and return back an array. So how is this thing gonna work? Well, we need to pick, right? We need to pick. So I guess first let's rot. So kind, array, and parser. We need to rotate twice, actually, or it's kind of weird. Yeah, I need to rotate twice, right? So rot prime maybe. So we have kind as well. Although, I mean, yeah, it's fine. So I would then maybe dupe 2. We have p and kind. Here we can swap these two together. So I can say stack parser peak, and we got a token. right? And we can take the stack token kind of this token, so it's the kind of the token. We can check if they are equal, and that just cancels out. Right, so here we need to return an array. So if they're equal, if we actually found the end token, right, what we need to do is, well, basically, first of all, we just pop the kind because we don't care about it anymore. We stack parser read and pop the result of the read, because the result of the read is just a token and we already know its type and whatever, and we are left with array. So that's the base case. Base case is when we find the end token, and it can be anything, right? Parse until. We can reuse this one for else's and for ifs. That's what I'm thinking. But it can only be like parsing expressions, so yeah. Anyway, so then we have to parse an expression and append it to the array. So I have to do something like, okay, so at this point we have array p kind. So I don't think we need a kind anymore again. I can just pop it. Right, I can just pop the kind. Oh, no, actually I need it to send it to the function. So let's see. So we'll have array p kind. Right, so what do I need to do is to parse an expression. For that, I think I only need the parser. So I can swap and dupe. So we get pp, and then stack parser parse expression. So this might give us an expression instead of p. Right, it's going to give us an expression. We also have the kind of the, not really. So it's going to be just the stack ast expression, right? Stack ast expression, and it's fine because the function has a body of expressions. So I'm pretty sure it's going to be fine. All right, stack ast expression. So we get the expression, we have an array, and we need to append into this array the expression. So let's just say we have the array kind p output. Obviously rot4 is needed to bring the array forward. Next I would dupe and rot, so we get array and expression, and then array.append. But I think std I think I need to make it a pointer. Stack st. Right, I think I need to make it a pointer to be able to append it. Anyway, so I need to like take the reference and then append it. Nice. All right, and we parsed the expression successfully. That's hopefully. Okay. And about this one, and then we just append it, right, and go again. So to go again, I need to swap these two together. So that's like, so here we have the kind parser array. So to do that, I will rot prime actually, right, to move array back, swap these two around, and then rot forward the array. So now it looks better, and you can just stack parser parse exports until, and should give me the array of expressions. Right. So I'm not sure if I want to dupe. Maybe I want to dupe. Then stack token end. That's the thing we need to add. And we need to initialize stack st expert size of array init with sz. So this initializes the array. This is the token we need to use for the until statement. And here we get back name, parser, and array. So that's why I'm not sure if I don't care about the parser anymore, right? Or do I? I don't think I care about it. So then I don't dupe, and I get all of this stuff. Right, and then I can just stack st function init, and I get back the function, right? So data stack st function. It's a node and an array, and that's what we have here. I have an array append at some point. Okay. So all of these are fine. This one, and this one we converted to a pointer, but here we didn't. So I said we swap. We take the features from the st, we swap again, and then I called append, but I think I should call stack st feature reference. Right, because it needs to be a pointer. I mean, we would have gotten the error anyways, but yeah. So this is parse until, this is parse function. It should parse functions and append them to the st. Let's actually see if that's happening. Okay, we don't have parse expression. We don't have parse expression, I mean, yet. We'll just add it. So function stack parser parse expression. It should take a stack. I think it's only stack parser, right? I guess, and it returns a stack st expression. let's see what's next. Okay, so parse until expected something like parser int array, but got array parser bool. Where does the bool come from? Oops. Oh, I guess from the, yeah, whatever, array parser bool. So parse until it expected something like this. Where is parse until used? Okay, because append returns a boolean, right? Yeah, returns a boolean. Okay, so we need to unwrap that. Okay, so if we make again, it should start to only complain about parse expression, right? But we also have one here, 274. Again, left hand side is stack parser AST, and right hand side is just AST. Huh, it's not good. We should also return the parser on the right hand side. Why do we pop twice? I guess we should only pop once then. All right, and shit, we still have a, oh, stack parser stack AST. Okay, so then we need to swap. Anyways, these are just to do's, so it doesn't matter anyways. Okay, expression is fine, and then we have this 285, and it should be stack parser parts, right? Okay, and it says that 291 is probably here. I put an extra true here, so as I said, we are not gonna do booleans here anymore, which is kind of not ideal, because if we fail the parse, we should stop. But what I'm gonna do is add here a true, and yeah, because I know it's gonna fail like with a to do in case it's not okay. All right, so here when we parse an expression, might be a bit more to do with it. So we have a few cases, right? If it's a name, a number, boolean, string, these are all easy. We just read one token and that's the expression. It's gonna be interesting for the if statement, but we'll get there, right? Let's do at least these. So how do we do that? We pick the parser again. So we pick the parser. Obviously, we just need to duplicate the parser, pick it, take the kind of whatever was there. Should I dupe? I think I should dupe the token, because you can see here. Well, yeah, I think I should dupe it. Or wait, 1 second. So parser pick is gonna return next token, right? Parser read, what does parser read return? It returns pick. Okay, so I don't need to dupe it. Okay, perfect. So it returns, if you think about it, parser big returns next token. Parser read will return next token, but also move next. So that's the idea. Okay. So here we duplicate our parser. We pick the current token. We take its kind. And if it's equal to stack token number, let's say, I think number is the first. Check its name. Anyway, if it's name, we have the parser, right? That's what's left on our stack. Apparently we want to return expression. That's interesting. So let's say we get a number next. Let's add also boolean, right? Boolean. Let's also add string. I think it would be cool to have an else if statement, but that's gonna happen not soon, I would say. Token if, and the reason why is because now I have to say how many ifs I have. 1 2 3 4 5, and then 1 2 3 4 5. It's a bit annoying. Anyway, so the else case is gonna be annoying because I have to do a to do, then pop, and how do I stack as the expression? It needs kind and pointer. It needs a kind and a pointer. I mean, I'm gonna put 0 and reference it or something. So it's like 0 int pointer, right? That should be okay. Yeah, like whatever, it's just would be nice if the to do or panic would also take care of the stack. So it's like, oh, the stack doesn't matter in this branch if we have a to do. Like if you know in Haskell you have undefined, and if you use undefined it literally matches any types, so it's not doing type checking in that branch. Something like that would be nice, but I mean, it is what it is. We don't have that. Okay, so let's see. I will just add this everywhere. I mean, it's just for the to do, so it's impossible to reach this place anyways, right? Maybe adding a function init.0 would be cool. And like imagining that somehow that function is like generated for each data structure, and it's like a null, but yeah, I mean it's a bit annoying that I have to do it like this, but let's see if we, oh, it compiles, nice. So if we try to parse it, we get a to do at 275. Let's try to see. Okay, I mean obviously it happens because we don't have an in. So let's go to empty and let's try to make it compile, right? So as I said, right now we don't have any types or type checking, and we are with 256. So we have to tokenize a number. This shouldn't be that difficult. What I'm gonna do is stack. I'm gonna do a dupe. Actually, I'm just gonna do a stack parser read. Right. So we are gonna read the token. Then I'm gonna do so to initialize data ast stack ast expression, we need a pointer, and as I said, we need some stuff from here. Actually, I think I need to do parser. So we need to initialize we need to initialize a number. Right, we need to initialize this thing. So I'm gonna duplicate the token and then call something like stack token value swap stack token position. So we'll have parser value position. It's perfectly in order for stack ast node. Init. So we have a node. We have to reference this node to make a pointer, and then we have to put this thing in swap. So we have the kind and the pointer, and we can just initialize the expression, right? Let me see if I can just combine some of these lines together. Maybe like this. Or even like this. And I move this one like here. So we get the, actually we get the node. So we have the parser and the token, then we convert everything to a node, and then we just have the expression. Okay, these ones don't need because we already know expression. So this should still compile, right? 254. And now the error happens here because we read the number and now we read the name. And what is the name? It's a plus, right? Oh, actually we read two numbers. That's kind of cool. I can do something like, for example, here, just for the moment, dup string.concat string.stdout, right? And if I need to remake and then run, right? So we read the numbers. That's kind of cool that we are able to actually parse stuff at this point. Okay, so let's copy paste this into here. So we get parser token, then we just build the node as usual, right? And we just say that this expression is a name, and this should be enough. We need to rebuild our compiler and run it. 345. So now the to do is a 345 at AST dump. So we actually just read the AST, right? We actually just read the AST. Let's try to implement stack AST dump. I mean, dump is gonna be a bit more annoying. Let's try to do it. So we get the stack st. Stack st has an array of features, so we'll need an like iterator. Stack st dump prime. Let's say it's gonna take integer index and array of features, doesn't return anything. And so I'm gonna do 0 stack st dot features stack st dot dump prime. So we are here now. All right, let's duplicate the array. Let's do something like array dot count. So we basically have I array count. I can just rot, bring this here. If greater or equal, then we break. So at this point we only have the array, but that's not good. So I should dup2 instead. So we have the I left here, right? So it would be like array like that. This converts to count. Oh, so then I can just, if it's smaller, then it's the recursive case. So we just remove all of this. Is the recursive case, else is the base case. So we don't return anything. So we pop 2, kind of. Okay, so here, let's not forget at some point, at some point we'll do I plus 1. Let me just I plus 1. All right, let's not forget about I plus 1. So I would dup2 again, honestly. Dup2 again. Swap. So we get I array I. And here we can do array.get. And what do we get here? Pointer. From what I remember, array.get. Pointer and boolean. So we can also unwrap the boolean, right? So we get a pointer. And what's interesting is that this is a feature. So we can just stack st feature deref. Hopefully this doesn't explode. So here we have a feature array feature. What can we do with this? Well, we need to check for the feature kind. Yes, we need to check for the feature kind. And feature kind is just stack st feature dot kind, right? So stack st feature dot kind, but I think I want to duplicate the feature though, because we need a feature at some point. So let's dup it. So we have feature and kind, and now we can just match on the feature kind. And the thing is, we don't have that many kinds. We only have data or function for now. So let's just dup that stack st feature data equals if the else. So at this point we have I array feature, right? And we need to return nothing probably, or something, but I'll need to figure out what. So we have another if, with a fee and an else. Right, so this should be func, but I need to figure out what do I need to return, because as I said here, we need to stack ast dump prime, so I guess I and array. So let's put, as I said, 1 plus swap, so we increment I and move forward. So on the else case, obviously we pop, like we to do pop. This is kind of an unreachable case, but I'm just gonna put a to do comment, you know, to do pop, and then everywhere is like to do pop actually. Let's see if this thing compiles. It means I have mistake with the ifs. Usually that's the case with this recover from. So mains, I have a syntax error, I mean 671, and this one is parse condition, obviously, so we are on the else case. Recover from error because I didn't parse the expression successfully. Shit. This is annoying. Oh, I see it. No, I'm actually surprised that we have so few syntax errors. 3, 4, 9. So here we have function kind has a wrong thingy there. So here I duplicated. Why the fuck did I duplicate this one? I don't know. It is what it is, and it isn't. Okay. Stack st dump. Yeah, it should be a dot. Who cares? And the last one is stack st features 362. Let's see, 362. Stack st features. Oh, so I would say features 0 swap. I mean, a rookie mistake in 50. We're getting closer. So we have to print a function. St dump. Let's see how do we print a function. Yeah, it's a rookie mistake in the world of stack developers, right? So we have to do something like func std out. Should I std string.std out, or should I concat strings? Then we should print the function name. So we have a feature, right? We have a feature. It's a pointer. So we need to take the feature out of this thing and convert it to stackst function. So what do I have to do is stackst feature dot feature, right? Then this thing is gonna give me, instead of feature, I'm gonna have a pointer, right? Then I have to say stackst func dot dereference, so we get a function let me just, so we get a function there. And what's next? Next would be probably to do a dupe, but I'm just gonna do a stack st function name. This is gonna give me a node, stack st node dot value, and this is gonna be a string. So I can just that, and then a new line, string.std out, string.std out, and that should be showing us the function name. Nice. So what's next is to print the args, the returns, and then the body. Interesting, for the body we have an indent. Right, which makes sense, but yeah. I mean, indent comes from inside of this. Like, indent is gonna be just for the outer stuff, so it's fine. So let's print the body next, right? We need to print the body. So then, as I said here, I want to duplicate. So here we have the iArray feature. Here we are gonna have iArray function, right? Because we duped the function. iArray func. Next we need to say something like expressions, right? Expressions, yeah. So stack st function dot expressions. This should be an array. Interesting. So we have exprs. And here I want to do something like body new line, right, and string.std out. I think I'm gonna have indent is equal to 2 initially. Do I have a stdlib? String repeat. Yeah, string repeat. Stack st dump indent is gonna be a 2. So I can do something like stack st dump indent string.repeat, right? It's string repeat, yeah. Then string.std out, and then I just print also the body. These ones are useless, so yeah. So we get the expressions, and I should have something like stack st dump exprs, and exprs should only take the exprs from this thing. So I should be left with I and array. All right. But I'm also thinking that, whoops, I'm also thinking that expression dump should take the indent as well. So this is the indent, like the current one, and I need to add the increase to it, so like this. So it's gonna, the stack dump expressions is gonna take expressions and indent. Or maybe should it be swapped? Let's say it's gonna be swapped. So exprs is gonna be the indent, array of expressions, and wow, I mean the dump itself is pretty difficult, to be honest. Jesus. So we'll have expressions prime, two integers here. We need to say, you know, first is maybe indent, the other one is I and expressions. So here I need to say 0 swap stack st dump exports prime, right? Just because we don't have while loops, we have to use recursive functions. Yeah, that's nice though. Dup2 array.count less than if we get, weird how here I said array, it should be, oops, end array. So we get indent I exprs else v, this thing shouldn't return anything. Okay, and what happens when we print an expression? Now that's interesting. Well, let's do to swap array.get unwrap stack st expression dereference. That's kind of indent I exprs and expression. I should have a bunch of if statements for expressions, if I'm being honest with you. Oh, I don't. Yeah, that's the first time I have that. Interesting. Right. Don't really have that. So stack st expression.kind. Do I? I mean, it's weird because I'm pretty sure I... Yeah, I had. So here I was doing something like duplicate the expression because I might need it. So let's see what's this gonna indent I exprs expr and kind. Alright, so I kind of lose the indent. So maybe it's like I need to bring it a bit forward. So like a rot4 swap for instance. So we get I, because we don't need I and exprs for the next step. We get indent and expr. So we just move this thing a bit forward. Right. Then obviously I need to dupe it for equal check, like that. Expression and kind. And these are gonna be, we're gonna decide what's gonna be there, but we kind of need to decide what's going to happen here. So here I need I and expers back. So it's going to be to do pop3, right? And again, swap 1 plus swap. Actually also indent, let's not lose indent. So rot 1 plus swap, so we bring I here, then we bring I forward, add 1, we rotate expression front, and then we stack stdump expressions prime, right? And this returns nothing. Okay, so all of these should actually be pop2s, right? To do's. Let's see if we have any errors so far. No errors, but we get to do 352. We need to fix this one. So this one is a number. How do we print a number? I guess we just print the number. Nice. So we don't need the kind because we know it's a number. We need to dupe 2 after this one. So we have I, expers, indent, expert, indent, expert, right? I mean, I don't know if I need to dupe 2, but it's better than dupe 1. So swap, indent, I need to print spaces. So I'm gonna swap again, string.repeat, string.stdout. So this thing is gone, but I have some spaces in the front. And then I need to print the number. So I'm gonna do stack st expression. Stack st expression, it's a pointer. So I need to take the expression out of this thing. Right, and now we have a pointer here. We have ptr. Right. And since we know we have a number, we can just convert to stack st node. We can just convert to stack st node via this thing. So we get a node, and from the node we can easily take the value. Okay, stack st node dot value. So we have a string now. So string.stdout, and then new line string.stdout. So we just remove it, and then we pop it. We pop this thing, and we get what we needed. Right. So let's see if this thing is now doing something different. Okay, we see the numbers and another to do, and probably the to do is here, right? We need to print the name. So we know it's a node, we know it has a value. That should be everything. And yeah, we actually get this thing. We actually are able to parse. Let's see if we can parse the first test case. Oopsie doopsie. 279. I guess, yeah, we won't be able to parse the first test case because we don't parse yet the parentheses. So we need to add those. But yeah, for the start, I'd say this is pretty nice. We can add like strings and true so we have more work to do, right? 217 empty 264 264. So here when we need to parse a string, right? Well, it's exactly the same thing. We read once, we take the value, but this time we just put a string. And guess what? Boolean is the same thing, so we don't need to wait for the error. Only if statement is going to be a bit different, but yeah. 264. I forgot to make ache. 361. 361. So if we want to print a string, I think it's just that, and boolean the same thing. Right? I don't see why they would be different. Yeah. So I mean, we are able to parse the basics. We don't have a full parser yet because yeah, I mean, you can see we have a lot of to-dos, right? I mean, if I search for to-do, it's not that many, but we need to add data types, constants, imports, then solve the imports, solve the constants, generate all the function getters and initializers. I mean, it's quite a lot of stuff to do, but it's, I don't know, I would say it's kind of repetitive. So again, as I did for the lecture, I might try to just do as much as I can for the parser, and maybe we can try to see how we can do the next step, which is, you know, solving the imports, for instance, which is gonna be a bit more interesting maybe. And this time we can try to even make the imports actually work. But yeah. So, you know, the other thing I said was if we were able to maybe go to the main function and actually call the assembler. Right. So what would happen if I just 818? Wait, what? That's strange. Why would... Huh. What the fuck? I mean, here it's std anyways, but that's beyond the point. We get an unwrap here. I mean, probably I'm doing something wrong in the parsing category, right? Hmm. That's weird. Let me just next develop again. I don't know why that error though. That's so strange. Like, it works. It's so weird. It works when I It works when I pass an F, a P, but it doesn't work when I... Okay, that's crazy. The fuck? This is really a what the fuck. And I had another what the fuck moment yesterday, like literally comparing index with the like array length, and the index was 0 and the length was 4, and it was crashing. I mean, this was in the C code, which is even weirder. I had a comparison which checks if index, so I can even show you. ds array dynamic array get ref. So I have this check if index is greater or equal than count, right? I know they are like unsigned ints, right? And index was 0 and this thing was 4, and it was showing me an error here, like literally that was insane. And the reason, and I still don't know why that happens, is here you can see it's a void pointer, so it's like an address to the destination, right? And I was passing, instead of a double pointer, I was just putting a single pointer. But I don't understand how that affected this if statement, because I mean, segmentation fault, sure, it would happen here because I was sending null in this thing. But even then, like, what the fuck? Anyway, that's you know, a detour, but I have no idea why this panics. Like, this is so weird. Like, how does minus p matter? The fuck? I mean, I would just add minus a, but it's so weird. Like, what the fuck? I have to figure out why that happens, because it's extremely weird. Like, that doesn't make any sense. But yeah, we'll see why that happens. I mean, I'll try to figure it out, but for now let's just add the assembler flag, so we don't even care about it. Bool assembler, it's false by default, and here, yeah, like extremely, yeah, a lot of weird things happening with this. And it's funny because Valgrind doesn't really show errors, so I wouldn't really know. Okay, anyway, so we can just remake everything and just pass a 8 to 4. That's funny. It still crashes. It still fucking crashed. But if I give it minus p, it doesn't. That's insane. I mean, I don't even know what to say about this one. What if I don't give it anything like this, and I just examples 0 0 empty, right? What if I'm pretty sure that panic is not right. Maybe it's my the code that expands the panics, which shows me, okay, it's a panic here, but it's actually a panic somewhere else, and I'm just dumb. with a C code, so it literally, yeah, I guess it's panicking somewhere else, so probably somewhere like here. All right, in stack assembler emit, let's say, because I'm pretty sure I added some like these ones are good. Okay, where does the error happen though? Hello, string.stdio. And like I'm pretty sure I messed something up in the panic macro. Right, yeah, makes sense. So it means that it's somewhere here where it's panicking, which I'm not sure why. Oh, so it's before that. So maybe it's in this one. Okay, but how would it panic here? Because I'm not doing anything that generates a panic, I think. Yeah, I'm not doing anything that generates a panic. Stack assembler init. It's not a function that panics. Okay, maybe I was just blind. So stack assembler emit. Does it panic in the emit? Where is func emit? So it tries to write the file descriptor of the assembler. Oh. What the fuck am I doing? Why am I trying to write the file descriptor where I read from? That's so strange. Yeah, I mean, does anyone remember why I did that? Because I don't, honestly. Like I said something about printing the file name, but no idea why I did that. So we don't need this shit then. So here we can just swap because we don't need a file descriptor. Here we can just swap. File descriptor again not needed. File descriptor not needed. File descriptor not needed. These things not needed. Right. Swap. And now I initialize with fd, and the fd is going to be std out. So I just let's think about it. So initialize with fd, right? Initialize with fd. It only needs the file descriptor. So I initialize the stack assembler with the file descriptor of std out. Gives me a stack assembler. So we have the AST and the assembler, and stack assembler emit should swap and take, yeah. So that's all. And then because I needed to close. I mean, yeah, that's true, but eight to nine. Lexer expected. Oh, so I don't even need to swap here. over here, for instance. Oh, it expected stack lexer, stack args.lexer. Huh. Dumbass. So here I swap because apparently I need args. But then I literally need to swap. Then why does it complain? What the fuck? Oh my god, stack args. So here I still have the file. Okay, let's keep the file descriptor because it's really annoying. So we have the file descriptor, right? fd because I call dupe. Oh my fucking god. Okay, let me just do undos until we get back to this point. So that's where we found the bug, right? Because I'm a dummy dumb and I don't initialize with stdout for some reason. So we put the assembler at the top of the stack like this. Then I swap and stack assembler emit, which gives me these two guys, and that's it. I mean, I should have maybe put the 6 to 8. So here, when we emit the AST, I mean, I have to do this part, which I mean, I don't really have time to do, but yeah, we would just emit the functions, right? But you can see we still get all of these, but I need to emit the functions. Shit. Like here, yeah, but yeah, I mean, I don't have time to do that right now, so maybe we'll see if I can do like a small follow-up, but if not, then you know, we'll see when we are gonna work on the, actually maybe we can start with this and then do some more stuff. I mean, I think, yeah, I'll do like a follow-up maybe and have like a break. So yeah, let's see with emitting the AST of the functions, right? Like iterating over the features. So it's like what we do here, iterate features and match on kind. If func, we already know how to print the function, right? Like we just need to redo this part to work for multiple features, but yeah, we already know how to print a function. So yeah, that's all for right now, and let's take a small break, and we'll see when I have to do the features. So yeah. Okay, so let's try to actually iterate the features, right? So that's what we wanted in this spot. Okay, so how can we do that? Well, I guess I'm gonna have a similar function to emit functions, but I'm gonna call it emit features. Features, right? So we emit all the features at once. So this is gonna be the features array, kind of, right? And then here we call recursively to emit AST features, right? And this is gonna be that function. So we can just, I mean, I'm just gonna take this one because we won't have emit functions, right? It's emit features. This is an array, array of stack ast feature, right? And what do we want to do here? Maybe I'm gonna keep the same, yeah, depends. Sometimes I used less than, sometimes I used greater than, doesn't really matter. We'll have for loops in some time, but not today, obviously. So we duplicate and take the array count. I'm gonna say feature here. We duplicate and do some rotates. If we are at the end of the array, we stop, right? And if not, we come in this place. So we do an array get, we unwrap the result to get the pointer, then we stack ast feature, actually, right? We take a feature, so this is a feature, and we dereference it. It's pretty good. Okay, and then we have some rot, and then we call to stack assembler emit function, but here we'll have emit feature instead, right? But for now we'll leave it like that. Feature, we increment I, and we recursively call to emit features. So actually, if we call right now to features, so stack st features, we should in fact emit the features at this point. Okay, so let's see this function where it is defined. So it's up here. As I said, this one should be features instead, but I like to have this one as function because we are gonna have functions but also feature. Stack st feature. Okay, so this is a feature, and here we call to emit feature. All right, so what is a stack? Stack st feature. It has a kind and a pointer, right? So this is the definition. Okay, let me just anyway. So it has a kind and a pointer. All right, so what I'm gonna do is probably dupe the feature, right? So we have assembler and feature. We dupe the feature, then we take the stack st feature kind. So now we have a kind. Honestly, I will dupe it, I think, and then say something like stack st feature data. If it's equal to data, then we have an if, else fee, and we have the same thing here, and it should return nothing at the end. All right, so here we have assembler, feature, and kind. Here it should be func. Okay, so what can we do is to do pop3 and to do pop3. All right, let's see what happens if we run make. I just need to add another p and then an else to do pop3. Right, let's run make. Stack st feature count has no matching args 617. So here I'm like, I have to do only that part. Anyway, right, and if we run the assembler, we hit a to do in here when we have to do the function. So we have the assembler feature kind, right? So we pop the kind because we don't need it anymore, but then stack st feature dot feature, and that is going to give us a pointer, right? And it's a pointer to stack st function. So we can just stack st func dereference, right? We dereference the function, and at this point we have assembler and function. So we can just call our old implementation of emit function, and it's gonna clear the stack. All right, so that's all that we have to do. So now if we run make and we assemble the thing, we actually got example.asm. We fuzz example.asm into an O file, and then we link into example.o, and then we run example, for instance, and let's see the status code. So 1. But why is it a 1? 0 0. Oh, because I added some garbage on the stack. Okay, so if we, I think I have to run make first just to make sure. And now if we run this thing, we actually get the result. So we actually read the file, we compile the file into assembly, and we did that using our like the actual code written in stack. So it actually was able to compile. It's a small subset, it doesn't have the types yet. I'm gonna add the types myself, right? It has strings, so you saw that this should print 3, I think, because it's the length, which is the first thing in the pointer. And we also have like booleans which work, right? But we don't have data types. I think we should be able to call functions, so let's call this one plus. I think it should work to call functions. It actually is. And what if we say it's actually minus? It's gonna be like 241, yeah, because it's minus 17 or something. Yeah, so we are actually able to compile the language using the language itself, right? So that's pretty cool. So what I have to do is basically go through each of the to-do comments, right, and just implement them iteratively. So that shouldn't be that hard. And honestly, error management, for now I think I'm just gonna panic on the first syntax error that I get, right? And we'll try, like, maybe in the future when we have for loops and better stuff, yeah, we are gonna try to manage the errors properly in the parser. But until then, no thank you. Yeah. And yeah, next time we should actually add imports and constants, right? Because those are important features of the language. Right, they'll allow us to import other files like the stdlib, and yeah, would be quite nice to have that. And it's also I really like how the panic keyword doesn't work at all, like the line and whatever, but I think the expansion of constants is going to be better actually implemented in stack than it's in C. So that might be helpful to actually try and do. So yeah, I'll just have to add all the types and all the types of expressions, fix all of the to-dos. There aren't that many, honestly. So, and there's also to-dos on the else's, so you have to keep that in mind. It's actually not really 15 of them. It's like just data, probably just consts and imports. So yeah, that should be everything for today. I think it's a pretty good result. We are able to actually compile stack code with stack code, so that's kind of nice. And actually execute it as well. So we just got, it's like what example is a statically linked file. Yeah, I mean, we just got an executable compiled with itself. I mean, it's like Inception level difficult to think about it. So yeah, I mean, let's not think about it. It's really weird, but we'll see next time. And yeah, hopefully I'll have the parser completed at some extent. Yeah, it's not gonna be perfect. It's not gonna handle all the errors. It's just gonna try its best. Let's just put it like that. And yeah, we'll see if we can add some preprocessor. So it's gonna be, let me just scroll up. Oh, I already lost it. So it's gonna be data stack parser. Wow. I mean, yeah, it's just gonna be adding all of those stack st function, right? Stack st node, yeah. So I'm just gonna add, we have features. For the features, I'm probably gonna add something like preprocessor, right? These are the preprocessor ones, and so on, like the imports and the consts. So yeah, thank you for joining me today, and we'll see in the next one. So see you.